Okay, our next speaker will be Nick Silverman from the University of Montana and SGI Science.
Thanks, Brady, and thank you all for being here. So I guess I would say this whole project really piggybacks off of the hard work of all the projects we've heard previous to mine. You know, the work at Bridge Creek that Nick and Joe Wheaton have done, the work at Gunnison that we heard from Nathan and Renee, and then Maggie Creek, the work of John and Carol. So I think it's kind of ironic that my presentation is going to piggyback off of all of their great presentations previous to mine, providing these really awesome on-the-ground analysis and figures and graphics that really show how effective these are. So what my talk is going to do is I'm going to go back and revisit some of these projects that we've heard about. And this time I'm going to look at them from about 450 miles above the Earth's surface using Landsat imagery. So I think this provides a couple of advantages. One, it allows us to look at different projects using different techniques from different areas over different time periods. And the second one is if we can see these changes using pretty crude 30-meter resolution images from space, I think it really hammers home the effectiveness of these techniques. So to start off, a little bit of theory behind this evaluation. We know water enters a watershed mainly through precipitation. So if you imagine you have a single drop of water that comes into a watershed, this drop gets partitioned into 4 buckets. The first bucket, evaporation. This is what comes right off of the landscape into the atmosphere. The second one is the water that plants use through transpiration. And then obviously runoff, which eventually turns into stream flow. And then finally natural storage. So this natural storage bucket, this is the important one. You can think of this like a bank account or a piggy bank that vegetation can use when it needs it most. And so by looking at changes in transpiration, given the same amount of water input, through looking at the productivity through NDVI, from satellite imagery, we can get a good understanding of what's in the ground being stored, and then from that we can imply gains in resiliency. And so that's kind of the theory behind this evaluation. So I looked at 3 of the case studies that you guys have all heard previous to mine. The first one is the Gunnison project in Gunnison, Colorado. This is a project that primarily used Z-dike structures and a little bit of grazing management as well. This project has been on the ground a pretty short period of time, 2 to 5 years, some of these structures. Then I looked at the project you just heard from Nick about, the Bridge Creek project in Bridge Creek, Oregon. This project used the Beaver Dam analogs and has been in the ground almost a decade now. And then finally, I excuse me, looked at Maggie Creek over in Elko, Nevada. And this project was primarily a grazing management project, and it's been in the ground over 20 years. So you can see we have a nice range of geographic location, different restoration techniques, and then different time periods in which they've been in the ground. A little bit of housekeeping on the methods. I'm looking at plant productivity in late summer, so July 15th to September 30th. I compare, where appropriate, I compare the restored sites with controlled sites that otherwise have very similar characteristics. And then where I don't have control sites, I compare before and after restoration using very similar precipitation years. Both of those are trying to get rid of the climate and weather impacts. Okay, so Gunnison. This is a project that started restoration in 2012. It's been ongoing since then. I looked at the oldest structures, so the ones that were installed in 2012, 13, and 14. These structures at the time were about 500. I think they're over 1,000 now, and several different locations around the Gunnison area. And as I mentioned, it also includes some of those drift fences that we heard about from Nathan affecting grazing management. So looking at NDVI, or plant productivity, you can see the red line here being the restored sites and the black line being the controlled sites. That pre-restoration, which is that dashed line there in 2012, we saw, good interannual variability. Those gray bars, that's the water year precipitation, so the NDVI fluctuating with precip as you'd expect, but pretty similar plant productivity there. After restoration, you can see a jump in both the controlled and the restored sites, but a bigger jump in the restored sites. And we've seen some of those on-the-ground photos of what that looks like. So from a NDVI perspective, when you look at the similar precipitation years before and after restoration, thank you. When you look at similar precipitation before and after restoration, you can see there's definitely a jump after restoration. This turns out to be about a 24% increase in plant productivity. So what does this look like? What does the satellite see? Well, you can see in August 2011, this is what one of their sites looks like. With the naked eye, you can see an increase in this green area by 2015. And if we look at a trend in the grid cells within these areas, you can see there's a lot of green. This is a positive trend in NDVI across the area there. So this is what it looks like on the ground, and we've already seen this photo. This is one of the Media Luna sites that they installed there. But you can see just really obvious increase in plant productivity that the satellite's able to pick up as well. Okay, so the Bridge Creek site that we just heard about. This is the Beaver Dam analog project. It was restored mainly in 2009. They put over 120 BDAs in the stream, and then as of present, there's about twice that from the natural beavers that have inhabited the area. So as Nick pointed out, this project's been heavily studied and monitored. It's been published on, and they also had set up their own controlled sites that we were able to use through our evaluation as well. You can see, if you zoom into one of their areas, you can see these structures from the air. As Nick pointed out, they're densely populated throughout these 1 kilometer reaches. Okay, so again, looking at these results, again, this is NDVI over time. Restoration began now in 2009. That's that dashed line. The black line is the controlled sites that weren't where the BDAs were not installed. And the red line is the restored sites. So you can see, again, pretty similar pattern there. When we look after restoration, again, big gains in plant productivity. And when we compare similar precipitation years before and after restoration, again, we see about a 20% increase this time in plant productivity. So this is what it looks like from the air. This is June 2009, and then compared with, again, June in 2016. Again, the naked eye can detect some of these productivity increases, but if we look at the trend across those Landsat grid cells, you can see a lot of green there. Again, that's a positive trend in NDVI. And this is what that looks like on the ground. You can see here, not only is the riparian area increased in plant productivity, but they're getting a lot of in-channel diversity, spreading that water across the floodplain, and really re-engaging the hydrology in the area. Okay, so the Maggie Creek site. This was a grazing management project. Restoration began in the early 90s. And it's restored over 80 miles of stream and riparian area. So I don't have a control site here, but fortunately we have enough time that we don't need a controlled site. So you can look, pre-restoration is everything previous to that dash line, and then post-restoration. And if you zoom in on that area and you just look at a trend in the NDVI, which is that red line, and you compare it to the trend in the bars, which is the precipitation, you can see there's really no trend in precipitation over the 20-plus years since they started their management plan, while seeing a strong trend, significant, in NDVI. So we're seeing sort of the same story across space, across time, and across methods. So this is what it looks like from the air. This is 1994 compared with 2016. And again, it's a little bit harder because it's a larger area, but you can see a lot of green in that trend of productivity. And I learned in Carol Evans' talk earlier that this is not actually Maggie Creek. This is Susie Creek, the adjacent watershed, but where they did a lot of the same sort of management practices over there. And so you can see on the ground some of these images that, that we saw earlier are of really impressive restoration. So we've looked at how much more productive are these sites, but probably the more important question is how much longer are they staying green? And to do this, I looked at the percent area above a certain NDVI threshold. In this case, it was 0.3. And I compared that for each month before and after restoration. And this is what those results look at Gunnison. And what you can see is the biggest improvement in NDVI is really happening in that late summer, early fall, about a 2-month period where you're really seeing big improvements. When we go to Bridge Creek, which again now, Bridge Creek's been in the ground about twice as long as Gunnison, you start to see now 4 months of time where the biggest, of greatest improvement. So we're seeing these areas are getting greener and staying greener longer, and the longer they're in the ground, the longer that window gets. And so again, if we double that time since restoration, we look at Maggie Creek, which is now has been implemented twice as long as Bridge Creek. You see a much larger window of improvement here, month to month. So this is kind of my take-home message, my conclusion and summary to all this. You know, if you look at resiliency, and resiliency is kind of a loaded term. It can mean a lot of different things. In this case, I actually tried to measure resiliency by the inverse of sensitivity. And so what I mean by sensitivity, I mean how much does this plant productivity change given how much precipitation changes. So you can imagine if precip goes up and down and plant productivity goes up and down, you would say that things are highly sensitive. The vegetation community and the hydrology are highly sensitive to those water inputs. If conversely you have precip going up and down and you don't see a lot of change, you would say that's low sensitivity or high resilience. So that's sort of the logic behind this metric of resiliency that I used. So if you look at that on the y-axis here, and you look at that of years since restoration, this is just at Maggie Creek because I have enough time to do this, you can see that over the first 5 years, we have really, really big gains in resiliency. And then after about 10 years, these things start to level off, or this gain in resiliency starts to level off. And so my interpretation of what's happening here is you're building up this piggy bank, this for vegetation to use, to the point where the inputs, you know, your income in your bank account is so large that it doesn't really matter what your income is anymore. You're rich, you know, you're flowing with resources, and so you're no longer limited by water. And this happens after about 10 years, according to Maggie Creek. Now, if we don't have the same sort of time, but if we put Gunnison on this same plot, and we look at what their resiliency is after 5 years, you can see it actually falls pretty closely to this curve. And if you do the same thing with Bridge Creek, after 10 years, you can see it's falling on a similar trajectory of resiliency. So again, just emphasizing that, you know, different methodologies in different locations over different time periods are sort of behaving in very similar patterns as far as gaining resiliency in the landscape. So that's actually all I have, and I'm happy to answer questions.
We have time for a couple questions.
Are you speaking specifically to one of the projects or all of them?
All of the projects are
Okay, so the question is, and I've gotten this question a couple times when I've given this talk. So what's the cause of, you see an increase in both the controlled sites as well as the restored sites, although you see a larger increase in the restored sites. So I think, I mean, one in we're really talking about the first two projects, Gunnison and Bridge Creek, because there were no control sites in Maggie. But in Bridge Creek, you'll see there's a bump in precip post-restoration. So I think they both go up because of an increase in precip. In Gunnison, it's a little bit more mysterious, I'll be honest. I was encouraged because I saw similar sort of results from Renee's presentation earlier, which also showed similar increases even in her control sites, which were totally independent of my control sites. So I don't really know. I think it's a great question. I don't know the answer to why those control sites also showed a bump, because we didn't see that same sort of bump in precipitation. Yeah, so the question is, are these results sort of outliers? If we looked at all the restoration around the West, would we see similar success stories? I don't. Oh, what's the number of restoration projects around the West? Yeah, so these are, I would say, representative of many different projects around the West. Obviously, didn't look at, we didn't look at any more than these three, but also didn't cherry pick these three either. These were the three that we looked at and that we've established collaboration with the partners with, and so yeah. So I think they're translatable across other projects as well. Okay, I'll repeat that. That was a correction on my previous answer. Yeah, so, and it's a really good point. Basically, the point is that these three projects, the thing that links them together is these are all low cost, low tech, low input solutions that have broad what you can see from space at coarse resolution results and positive impacts to the watershed. So, so I think that the point is that not all restoration falls under this this genre, and that what we're trying to show is that these sort of low cost, low tech methodology can really make an impact.